Merge two sorted lists. You are giving the head of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of merged linked list. Example 1. We have 1, 2, 3, 1, 2, 4 as the first list and 1, 3, 4 as second list. We want to merge those two and keep them sorted. So the result will be 1, 1, 2, 3, 4, 4. And for this question, I'm gonna use a iterative approach, and I'm gonna looping through both linked lists and then keep track of the node, and then I will compare the value of the node, and then I will point to the node with smaller value, and that's how I'm gonna do it. So first let's start coding. Then I will have this node. I will call it dummy, and then it will be a new list node. I will initialize to -1. So that's where I can store my new merged linked list, and then I will have another list node. I will call it cur to keep track of where is my current position at. So I will initialize this to be dummy node, and then I will have a while loop. So in the while loop, I will check. I will make sure that the list 1 is not now, and list 2 is not now. So I want to make sure, as long as I didn't reach to the end for either of those lists, I will keep the iteration going. And then inside of there, I will have an if statement to compare the value of the two nodes. So I will say if list 1 dot value is less or equal to list 2 dot value, that means I want to point my current node to that node with a smaller value. That's how we achieve the sorted requirement. So if we found this one is smaller, then I want to point my current dot next to equal to list 1, and then I will update my list 1. So I will say list 1 equal list 1 dot next, and else. So in else statements, it will be when oh sorry, I forgot list 2. So in else is when list 2 is less than list 1. In that case, I will have a similar logic. I will say current.next equal to list 2. We go with the smaller one so we can keep it sorted. So list 2 equal to list 2.next. Update the list 2. And then at the end of the conditional check, I will always update my current node. So I will always say current equal to current.next. In that way, my current node will always be at the tail of my sorted merged linked list. And then when the while loop breaks, we know that one of those we are at the end of the list 1 or list 2 or both of them. So I want to have a check. So if list 1 is equal to now, then I will just say current.next equal to list 2. And then similarly, if list2 is null, that means I can just attach the rest of the list1 to my linked list tail. I will say current.next equal list1. And then at the end, I will return the head of my merged linked list. I will return dummy.next, because remember we recorded our current head with dummy, so our current head will be dummy.next. So next, we can work through an example. So for example, for this example, I will create a dummy node here. S will be -1, and then I will start the comparison. So 1, 1. Since it's equal, I will choose to point to the list1 node. So I will say I'll point to this node, and then I will update my current node to here. And then I will compare 1 and 2. So 1 is smaller, so I will point to 1. Now my current node is here. Now I compare 2 and 3, and then 2 is smaller, so I connect to 2. Now my current node is here. Next I compare 3 and 4. 3 is smaller, so I connect here. And by do this in the iteration, at the end we will have a merged and sorted linked list. Next, the time complexity will be O of n, because we just loop through the input array once, and then the space complexity will be O of 1, because we just create a few variables and then we didn't create any other data structure, which means the space will always be constant space. And next, let's test the code. Looks like it's worked.